we want to write an equation of circle O, shown on that grid below. Whenever you write an equation of a circle, we write it in this form. X minus h squared plus y minus k squared equals r squared. Unfortunately, we are not given that equation. You're going to have to know it or know the process on how to write the equation of a circle for your test. Okay? It'd be nice if they could give it to you, but they don't. So in order to write the equation of the circle, the center, hk is representing the center. H is the x value of your center, k is the y value of your center, and r represents the radius. So in order to write the equation of the circle, you have to know those two things. You have to know what the center is, and you have to know what the radius is. They were really nice, and they told you what the center was. What are the coordinates of our center? It said center O, so you go to where O is. What are the coordinates of that? 1, 1. Okay. And then we look and see what is the radius. So when we write the radius, is that all the way across or halfway across? Halfway. So you start at the center and count to the edge. When we do that, what's the length of our radius? Our radius is what? We count from the center to the edge, we get what? 4. So now we know our center, now we know our radius, we can write our equation. It's going to always be parenthesis x. Whatever the x value of your center is, you plug it in for h. But what happens to the signs? If it's a positive one, when we plug it in, it turns what? Negative. Then we have a y. When we have a positive one and we plug it in, it turns what? Negative. The sign changes to the opposite. So the x value of your center goes in with the x. The y value of your center goes in with the y. Change the sign. And then it's equal to r squared. So your radius squared. If our radius is 4, what's 4 squared? 16. So there's the equation of your circle. That is your answer. You don't do anything else with it. Questions over there? Okay. If we take a look at number 2, it says the equation of the circle is shown. What is the radius? So when we're given the equation of a circle and it's not in standard form, so it's kind of this jumbled mess of x and y's and numbers, what are we going to use to help us answer this question? What are we going to plug this into? Desmos. Yes, we can plug this into Desmos. Okay, so you're going to go to Desmos. Okay, and type in it exactly how it is on your paper. Everything. You literally plug in everything. So you're going to plug in x squared plus y squared. So x squared plus y squared minus 10x plus 8y plus 16 equals 0. Even put the equals 0. If you don't put the equals 0, nothing graphs, and there's an exclamation point there, so that's telling you you need to put the equals 0. And then they graph this circle for you. Okay? Well, the problem is we don't know the center. It's not as nice as the first one to figure out everything. Okay? So we have to figure out what our radius is by just counting. Okay? How can we figure out the radius by just counting? What can we do? Yeah. Good. Count all the way across. Count your diameter. We count all the way across, we get 10, so that's the diameter. The diameter is 10, what's the radius going to be? What's 10 divided by 2? So our answer is 1. Okay. You can use this method if it's given and not in standard form. Okay. You can use it to find the radius, you can use it to find the center, you can use it to write the equation. Okay. Plug it into Desmos. and use the graph to help you find whatever it's asking. Okay? Questions over that. If we take a look at 3, it says find the measure of arc RS. RS only has 2 letters, so that means the shortest route between R and S is there. So whenever an arc is missing, go to the angle. Okay? What kind of angle is that, central or inscribed? Inscribed. And what do we know about the relationship between inscribed angle and its arc? It's, or not half, double. Okay? The angle is half. You're right. The arc, I made my words mixed up, sorry. The angle is half the arc. So in order to find out the arc, what do we have to do with 35? What do we have to do with 35? What? Times it by what? 2. What's 35 times 2? 70. So whenever you're given an inscribed angle and you're asked what's the arc, double it. And that's your answer. Vice versa, if you're given the arc and you want to find the angle, cut it in half. Okay? Questions over that? This one, there's multiple ways to answer this one. There's a shortcut way and a long-handed way. I'll show you the shortcut way first, and then talk about if you don't remember the shortcut way, how you can answer it. Okay? It says quadrilateral ABCD is inscribed in the circle below. Find the measure of angle A. So the shortcut way is whenever you have a quadrilateral inscribed in a circle, what do we know about the opposite angles? Are they the same? They look the same. Now, this is 74 degrees. There's this angle, it's smaller than this one. This is much wider. So they don't even look the same. So that's indicating to me that they're not. What do they add to? What do they add to? What do we get? What do these two angles add to? One of two things. They're not the same. They add to what? What do a lot of angles add to in geometry? 180, right? They add to 180. Right? So if they add to 180, what can we do to figure out? Subtract it from 74. We want to find angle A. This is the angle we're trying to find. It's opposite of the 74. I know these add to 180. So I'm going to do 180 minus 74 and get what? 106. That's our answer. That's the shorthanded way. If you take this test and this question comes up, and it often does, so this might be an important one to know, you can still solve it by not remembering that fact. Because we're dealing with inscribed angles here. Okay, so whenever an inscribed angle is missing, so we're trying to find angle X, go to the arc. We don't know what that arc is, so we need to find it. So we have to use the information they gave us to help us find that missing arc. Well, they gave me this angle. Okay, what do I have to do with 74 to find that arc? Going from little angle to big arc, what do we need to do with 74? Times it by 2. What's 74 times 2? Close. 1, not 58. 48. 148. So then what can we do, now that we know that that arc is 48, 148, what can we do to figure out this big blue arc? What do we know about the entire circle? It equals what? If part of it's 148, what can we do to find the rest? Subtract it from 360. 360 minus 148 is what? What is it? 212. So I know this whole arc is 212. Well, what do we do with the big arc to find the little angle? Divided by 2. And 212 divided by 2 is 106. Both times you get the right answer. One is much quicker, but if you don't remember it, use what they gave you on the diagram to figure it out. Use what you know about inscribed angles to help you figure out what that missing angle is. Questions over that? Alright, last one. The teacher draws circle O on the board, and then those two angles, ROQ and RPQ. The teacher asks the students to select the correct claim about the relationship. What is the correct claim? Are those two angles the same, or is ROQ twice the measure of RPQ? Claim 1 or claim 2? Well, what is it? Yeah, it's claim 2. Right? Because if we look, ROQ is a central angle. RPQ is an inscribed angle, and they're intersecting the same arc. Well, what do we know about the relationship between a central angle and the arc? They're what? Right? What do we know about the relationship between a central angle and the arc? It's the same, right? So hypothetically, if the arc is 30, what's the angle going to be? 30. Right? What do we know about the inscribed angle in the arc? What would we have to do with 30 to find that inscribed angle? Divide by 2, and 30 divided by 2 is 15. The central angle is twice the amount of the inscribed angle. So kind of play around with it. Pick up some numbers and see what you get. Also, if you look at it, those two angles really look the same. No, they don't even look the same. So if you're not have any clue how to answer it, well, they don't look the same, so I'm just going to be number 2. Don't always go that route, but if all else fails, see if they look the same. Okay? Because sometimes things just aren't drawn to scale. Okay? Questions over that?